This is an amplifier I've had for 3 or 4 years now. This was bought from a local seller who was selling it. Said it had an intermittent fault with it. He said that every now and then one channel would drop out, and he said that he thought it was something serious, and he wanted to get rid of it. And it was offered up for a reasonably good price. It was much cheaper than they normally are. So this is a Pioneer A757, and it's a beast of an amplifier. It weighs in at just under 20 kilos. It's dual transformer. Basically, it's not a dual mono amplifier as such, because the transformers do actually share the channels to a degree. In the dual stereo amplifier or dual mono amplifier, I don't know how really they describe it. Basically, you've got two mono amplifiers totally isolated from each other in one case, whereas a stereo amplifier usually shares the power supply and maybe a few other bits and pieces as well. Anyway, I bought this amplifier from the chap and got it home and used it for a bit, and then realised that every now and then, of course, I did lose indeed one channel, as he said, and all it turned out was just, the normal noisy selector switch. So I thought, well, probably what I'll do is I'll actually use this amplifier at home. But the trouble with this thing is because it's so bloody heavy, my rack simply wouldn't put up with the weight that this thing is. I usually use a Pioneer A400 at home that probably weighs 7 kilos maybe, but because this has got two huge great transformers in it, it comes in at sort of 20 kilos, and it's just far too much for my system. So it's been in the loft for a while, and I've just wanted to get it out to just check it over, just make sure all the switches are okay, because sooner or later I do actually want to start using this amplifier instead. From the reviews I've seen on the internet, it's supposed to be quite a good amplifier. You never know, because the reviews of these sort of amplifiers this era now are all done by people who own them. Well, there's no way I'm going to buy an amplifier like this and sort of say it's crap. So I think generally the amplifier reviews you find on the internet are all, have glowing reports of how good they are. So I'm just going to give you a quick run through it, and then I'm just going to do some contact cleaners, servicing inside, selector switches and things like that, speaker switches maybe. So just run through this front panel quickly. Now it's typical sort of Japanese Pioneer amplifier of its day. We've got a speaker switch on the left, the bottom here. So we just our selector switches here for the speakers. Pretty straightforward. It can drive A and B speakers in parallel together. Bass control, treble, and our balance. And this is our record selector. Pretty normal and very similar to the Pioneer A400 and 300 series. You can listen to one input and record on another. Common to a lot of amplifiers as well. We've got quite a good selection of inputs here. We've got tape 2, tape 1, compact disc, phonograph, tuner and line. And then we've got various options at the bottom. One of the interesting options of this amplifier is you can actually turn off the phono equalizer amplifier. Now, what Pioneer said was the reason for this was to reduce noise in the audio stream. Well, yeah, really. If you're not selected to phono, I can't believe that makes an awful lot of difference. But anyway, that's what they did it for. We've got a loudness control, which, to be give or take, I'm not that interested in things like that. This thing here actually allows you to sort of use it. One of the tape inputs, I think, is through a graphic equalizer or an adapter. You see here, so tape 2. And that's nothing particularly fancy. We've got a direct button here that basically takes out the tone control circuits and any of the other controls. You see the loudness control doesn't make any difference at all until I turn the direct switch off. And here we've got our phono selector modes. So we've got moving coil subsonic, which basically puts probably a 6 dB or 12 dB roll off below 50 Hertz, something like that. Moving coil without subsonic, moving magnet, and moving magnet subsonic. Pretty straightforward. And of course above here we've got our volume control, and our muting switch just to you know, mute the level back. Nothing particularly fancy. On the back, I'll drag the thing around. We've got huge binding posts here. I'll just drag it right around so you can see what's going on. So this is our speaker binding posts here. They're massive. The biggest I've ever seen on any amplifier. So that's great. You know, you can put a proper speaker binding post, or you can use wires. It's actually got the outputs for the switching of the mains, which is an unusual feature on an amplifier of this age. Usually they ditch this system by then, which is nice, because what it basically means is some of them are unswitched. There's one that's unswitched, but the two are switched. So it means you could plug in, say, a cassette player and tuner on there, and when the amplifier's turned on, all the other stuff comes on together, which is nice. We've got various inputs here. We've got the record tape players for here, tape 1 and tape 2, CD, various inputs. There's our gold connectors for the phono. Oh, this is the adapter, so it's obviously like a third tape socket almost, and that's for putting in a equalizer or something. And of course we've got preamp power amplifier couplers here, so we can use this thing as a preamplifier. Why you'd want to use an amplifier this weight and size just as a preamplifier, God knows why you would. You'd probably use it as a power amp, and you could use it, there you go, as the power amps there. So you just basically pull these out and you can separate the preamp power amplifiers. One thing I have noticed, and when I noticed it when I was just wiring up in the workshop this evening, this voltage selector is, well, let me just show you. I'm just going to turn the amplifier off. Now, you can see this where it's pointing at the moment. You can see it's pointing to 240. It's very easy. We won't do it now, but it's very easy to knock that round to something else. You see how easy that is? And when I got to the workshop, it was at 110 volts. So bear that in mind. If anyone's buying one of these, just be absolutely sure that you've actually got it on the right selection, because obviously if you haven't, you won't kill the power. I doubt if you'll blow it up, but you'll certainly blow the fuse if you've got it on 110 or 127. This, the lower ranges here, you'll just blow the fuse. And likewise, I mean, you could probably get the unit to work on 110 volts when it's selected to 220 or 240, but you'd obviously have vastly reduced power, and it would probably be tripping out all the time on you. So keep in mind that's easy to knock. I don't like that. That almost wants something put over it to prevent it from being knocked again, which is probably what I'll do. Now I've found it will do that. So the next thing to do is have a look under this, look the cover, and see look at all the beauty and goodness that goes on inside. And this is what greets you inside. It's quite a spectacular looking amplifier, actually. I mean, I know a lot of this is all for show. Output stage here, huge honeycomb heatsinks. And Pioneer used a lot of this in this era of amplifiers, this honeycomb structure to make the chassis very rigid. And bear in mind the huge weight of these transformers and heatsinks. You need something that's pretty solid. So we've got twin power supplies here. But if you notice, we've got two transformers, but we've only got 2 capacitors. Now you'd expect to see 4 capacitors. So what I'm expecting to see in the circuit, which I haven't downloaded yet, is one transformer does the negative side of the rail, the other transformer does the positive. So therefore, it isn't really a dual mono amplifier. It's actually still a stereo amplifier with just 2 transformers. I haven't mentioned the specifications. I've read that it's capable of, I think it's 95 watts RMS per channel into 8 ohms, but it can sustain 150 watts RMS into 4 ohms, which is pretty spectacular if it can actually do that. We'll try that later on, see if it can actually achieve that. There's not much more to see on the top of this board here, but this is obviously all the amplifier section here. All the power transistors are underneath. We've got, I don't know if you can see there, but we've got 4 transistors on one side and 4 on the other. So basically we've got the transistors are paralleled up to be able to cope with the massive amount of current this thing is capable of dumping into a loudspeaker. And just because it's this amplifier was obviously designed to be able to tackle sort of very difficult sort of 4 ohm loads, very reactive loads, and not sort of run out of puff sort of thing. So there's been no compromise at all to the build quality. It's absolutely, you can see it on the side. It's all, I think you can see this. The light's not great, but it's all honeycombed down the side here as well. And it's considering the weight of it, there's no flex in the chassis at all. It's absolutely rigid. It really is a tank. It's built really well, and it's going to sort of, it's not going to creak and bend on the shelves like a lot of these things are. Now, just looking at these output sockets here, and found something quite interesting. Look, you see even one of these connectors isn't even connected up, unless it's wired in parallel or something. Maybe it is, but they're the connectors on the back for the supply for the output. I'm surprised they're not insulated as well, but that's a bit ominous. And also can't see any sign of adjustments for quiescent current or anything like that, or DC balance. Now that might be done under one of the covers, and likewise that needs to be looked up on the manual, but I think I might do a power test on it now, just to see what this thing is capable of, and see if it's as impressive as on paper as it is by looking at it. Let's see what this thing can do then. So we're wired up to the audio analyzer, both channels driven into 8 ohms. We'll do our initial power test. The HP8903 is displaying watts on the right hand meter. It's this LED display that's on. We'll run it into clipping, and then we'll see what we get. We've got this scope on this stupid trigger mode where it doesn't run properly. It's better. Okay, so let's increase the push the amplifier into clipping. Just start to clip off there. It's a bit asymmetrical actually, but not too bad. Making about 100 watts into 8 ohms. Pretty spectacular really for an audio amplifier for the home. So let's try it at 4 ohms. You might even see the lights dim slightly in the workshop as it pulls current out of the supply. The supply in the workshop is quite high resistance, so it might pull the line down a bit. Here we go. Yep, doing 100 exactly as it says in the spec. 152 watts, both channels driven. The interesting thing maybe to do now is try a single channel drive and see how good the power supply is. This is always a good test for checking to see how good the power supply is holding up under duress. Because we're not driving one channel, there's more voltage available from the power supply, so there's less likely the power supply is going to sag. So I'm going to go on to one channel only, and let's see what we get. So we're back on 8 ohms again, and see what power we get on one channel. Oh, ignore that because we're still measuring 8 ohms. So it looks about 110 watts into a single channel drive into 8 ohms. Let's run it again. Yeah, about 110 watts into one channel. So that shows that the power supply is exactly very stiff, and it's holding up really well. So that's reassuring. But then again, you'd expect an amplifier with such huge transformers to be as good as that, really. So the next thing I'll do is I'll do our normal thing we do. I'll do a frequency response check. It'll be interesting to do a distortion test, because basically the distortion of this amplifier is about as low as the audio analyzer will measure. Now I'm not entirely, as I've probably mentioned before, I'm not entirely happy with the setup of this audio analyzer. I think I need to connect this audio analyzer up to the same socket that I'm testing the equipment with, because I think what happens is when we're drawing lots of current, or for other reasons we're getting circulating currents in the supply line, the main supply, and it's causing higher distortions than really exist. So let's just do a 1 kilohertz distortion, total harmonic distortion. So frequency 1 kilohertz. Take that ratio button off. Let's do it at the start again. So 41.0 special, that resets the analyzer. Frequency 1 kilohertz, amplitude 300 millivolts, and then we just want distortion buttons in. want it in percent, so we don't want ratio on, do we? Oh, come on. There we go. So you can see the distortion incredibly low, 0.06%, which is pretty close on the low. You know, that's as good as the audio analyzer will resolve. So distortion levels are extremely low. So I'm going to do a frequency response sweep then. So let's reference our audio and do a sweep. I've got a very slow sample rate on here at the moment. I thought I had the tones defeated, but I haven't actually. So let's run it through. This is with the tone controls active. You know, not turn. They're in the center position, but they're not defeated. Okay, so it's a little bit wavery, but it's within 0.1 of a dB, and you certainly won't hear that. 5 kilohertz. I don't know why this. I think my step time's been altered on this analyzer, but there's 10 kilohertz. Slight roll off. It's strange. Yeah, it's not constant, is it? It's sort of not smooth. It sort of ups and downs a bit. So let's run that through again. I'm only running single channel. I'm now going to turn the tone controls off. Let's run it again. Just check our frequency 1 kilohertz. We should be at 0 dB. Okay, it's gone down up slightly, isn't it? A bit jumpy actually. I don't know if that's a dirty pot. It might be a noisy pot actually. Even though it doesn't sound scratchy, it seems to be very jumpy to the volume control. So let's sweep again. Some quite odd readings actually, not what I was expecting. It's I mean it's pretty flat, it's within a dB, but it's moving around a bit. And it's certainly good. It's not a poor performance, but it's a bit erratic. It's sort of taking sort of steps. Not normally, they're usually much smoother than this. Okay, so yeah, it's not bad. It's plus or minus sort of half a dB or something like that. So certainly performance is pretty good. Those heat sinks are getting quite hot now, but obviously it's putting quite a lot of power into the load. So yeah, I think it's really concludes it. I mean, this is really all I wanted to do was test the amplifier, make sure it's okay. All I'm going to do now is clean the pots up and give them a service, switches and things like that, and put it all back together and try and reinstate it at home so I can actually use the amplifier. Anyway, thanks for watching, more to come. I was listening to this amplifier just in the background, sort of tinkering around in the workshop, and it became very distorted, one channel. That was initially what the seller was saying was the problem. I've never come across it, I must admit. I've had it on for a couple of hours and messed about with it at home, never been a problem. It became very distorted in one channel. When I turned the volume up, it sort of it had that sound like there was a lack of power supply. It was sort of like sagging away. When I turned the volume back down again, the distortion sort of went away and came back, and then sort of faded in and out, and then basically the amplifier was just sounded like it had no volts to the power supply. A bit like one of the old amplifiers when you used to turn them off and they faded away to nothing. So I'm just tipped it upside down and having a look underneath. This is the sort of like the pre-regulator side of it. This is basically the bit that does all the supply for the preamplifier, phono amplifiers, and all the sort of auxiliary circuits. It's quite nicely laid out actually. If you look here, it's the bottom of the power amplifier section. These leads here and here feed the raw supply to the power amplifier stage, the push-pull stage, and these two wires here feed the preamplifier. Now I'm going to look at those and check the connections on those. These are all wire wrap connections, so there shouldn't be problems with the connections there. But there's a couple of these TO3 transistor type regulators. This one here feels a bit like the joints might be dry. Unfortunately, to get the bloody thing off, it's got so many cables and wires connected to it, it's going to be a bit of a nightmare. So what the plan is to try and get this board turned over and have a look under the other side and see if I can see any dry joints or anything like that. Okay, I don't know if you can see this, but this is the TO220 device here. This is the pad that holds the heatsink in, so the heatsink's soldered to the board, and the actual connections for the transistor just here where my thumb is. I don't want you to see this, but I don't know if I can get the view good enough for you to see. You probably can't see this actually. But that transistor's got a dry joint. More than likely that's the problem. It's definitely a power supply problem, distorted sound. So I'm going to refill all those joints. The trouble is, because it's got a big heavy transistor on it, it's obviously the vibration of being moved about stuff has made it worse. So resolder these joints and I'll put the amplifier back together. Okay, this is the transistor that was badly soldered, or the regulator, or whatever it is, probably a regulator, TO220 regulator. Resoldered that. It doesn't look that great here, but the joints look fine. This connection here that you can see has been resoldered. It's very difficult to resolder. That's the connection to the heatsink. It's actually just a stay. It's not actually electrical connection, so it doesn't matter that much. But it's actually got the heatsink stable now. That's the other regulator on the other side. It's difficult to get a good image because the light blows overexposes the camera. That's the other connection there, and there's one more over here. This one here. And that's been reflowed as well, even though that one looked okay. There wasn't a lot of solder on there, so reflowed that again. Let's put this amplifier board back in, or this power supply board back in, and let's see what we get. Well, I got the thing back together again, and I thought I'd just check the phono amplifier, and the phono amplifier is totally dead. I've tried feeding audio in from a sort of high level signal, and there's nothing at all on the phono amplifier. Usually if you've got the phono amplifier on, turn the volume up with nothing connected, you get hiss. You get nothing on this. I've turned it to phono, no hiss at all. It's got a switch here to actually turn the phono equalizer on. Nothing, no audio at all. So that also looks like possibly a power amplifier, a power supply fault. So it looks like I'm going to have to take the epoxy thing apart again and check the supplies to the RIAA equalizing amplifiers and preamplifier section of the phono stage. But nothing at all. Really odd. Never come across a dead phono amplifier before, unless I've disconnected something when I was taking it apart, but everything was plugged in back in how it should be. So looks like the epoxy thing will have to come apart again, and we'll have another look. Now here's the problem. We seem to have a short between 1 and 2 of this connector here. Now 1 is this wire goes up to these transistors here, and they act as a muting. This is the muting circuit for the phono amplifier, and what it does is it basically turns these transistors on here and shorts the output of the op amps to ground for audio muting. Very straightforward. Now I've got no supply on, it looks like pin 2 of this op amp, this regulator, and pin 3 I think is okay. So there's a short, it looks like, on this line somewhere. Now I need to confirm that first, but if I go between pins 2 and pins 1 with an ohm meter, I've got 0 ohms. There's no obvious solder bridges or anything like that. It could possibly be one of these transistors is shorted, but it's a dead short circuit, so I'm not convinced that that probably is the problem. We've also got these couple of electrolytics here. They are possibly a problem. Now this connector here is on the phono stage. Let's see if I can show you it. It's not easy to see. Well, anyway, the phono amplifier is... the light's not very good, is it? The phono amplifier is actually this board here that's mounted in this sort of cage, which is a real pig to get out. So you track this wire back and you come down here. Where are we? Come down, 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 down. It goes to the muting board, this board here, which is basically the front panel, that in itself is a real pig to get out as well. But what it does is it splits off, and this is line 1 here that goes off to the muting circuit, and that's quite straightforward. It's like a monostable thing here, and then it's just a switch that enables the muting. Now that seems to work, certainly on the rest of the amplifier. You know, it's got a muting button that mutes on the aux and everything like that. But the problem is obviously the phono's not working. 2 and 3 that come down here, and they split off on this board and come to 4 and 5 of another connector that feeds to the power supply board. And the power supply board is this one down here. Now I've got the short still here on this end of the board, so what I'm going to do is I'm going to disconnect this connector here and try and ascertain where the short is, but I'm pretty sure it's on this side going up. I think the power supply side of it's okay. The only thing is, if there has been a short on here, we've got a couple of fusible resistors, and these fusible resistors could have gone open circuit. So I think what I might do is power it up with this connector disconnected and see if we've got any supply. I suppose we could find these resistors actually, just check them, see if they've gone open. But it's a simple sort of regulator circuit here, transistor, series pass transistor, linear regulator sort of thing. So let's have a look, see if the output's there when the connector's disconnected, but I don't expect it to be. Or I might just check the resistors. I think that'd probably be the easiest thing. I did buzz the transistors out, they looked okay, so yeah, I think I'll check the resistors. So let me find the resistors and we'll check those. Alright, this is frustrating and somewhat embarrassing as well, because I've had this board out to try and find out what's initially wrong with this amplifier. It looks like when I plug this connector in, and these connectors are horrible, they're these sort of like flexi wires, and you're supposed to connect them into these sockets here, but it's so easy to get them in the wrong position, or they cross over without you noticing and them short out. So it looks like this was in the wrong position. So I'm going to straighten the wires out on this flexi and put them into the right holes, and hopefully that will sort the problem out. Probably won't, but we'll try it. Okay, that's fixed it. Oh, that is really frustrating. I spent quite a few hours looking at this fault. Okay, so basically what was happening is the phono stage wasn't being turned on, and because I haven't had a lot of experience or a lot of use with this amplifier, I can't remember if this phono amplifier ever worked. So what it was when I took it apart initially to fix that dry joint on the regulator transistors, I've obviously put these cables back slightly skewy. This has prevented these 2 transistors turning on, and of course it's supplying power to the phono stage. There's a crossed wire here, there's a crossed wire there, and there are these connectors here. So if you're ever working on one of these amplifiers with these bloody awful connectors in them, be absolutely sure that you haven't got a crossed wire, because if you look at the connector like that on the edge, it looks fine. It's only when you take the connector out you realise you've got the wire, you know, 2 wires going over into one connector. So we fixed that. Excellent. Looks like the phono amplifier is working. I'm going to box it back up, and we'll try the phono stage with a signal from the audio analyzer, and just to make sure it's working correctly. Right, all back together. Seems to be working fine. So we can listen to this. So, what it was, let me just run through and reiterate what we found. Let's turn this down a minute so we can the video. Basically, when I replaced resoldered the regulators on the outputs, the power supply, to recover that lost supply to the power amplifier stage, I had to take this board out here, and I soldered the regulators, which are these regulators here on the circuit. That was the main problem initially, and that would have been the fault that was the amplifier came with. That the chap I bought it off said the sound became distorted and sort of garbled, and I initially thought it was a noisy switch, because I ran it for hours at home, never ever did it. And it was only a couple of days ago when I switched it on the workshop when it was cold, I noticed the distortion and then realised it wasn't a switch, and it had the classic sound of an old-fashioned amplifier being turned off. I remember the old sort of 70s, 80s transistor amplifiers. When you turned the power off, they sort of faded away and then became distorted as the voltage dropped off in the amplifier. Exactly the same sound, so recognised that as a power supply fault problem. So I resoldered these two regulators as one of those was open. But in the meantime, doing that, having to remove these awful cables they use, these IDC flexes. I mean, the flexes actually themselves are quite a good idea because they're quite widely spaced, so you get very little crosstalk between the two, not like ribbon cables you find in a computer or anything like that. Anyway, so what basically it turned out to be was I got two of these wires shorted together. So I think it's 4 and 5 I had in the same hole. So basically what that did was put a short across 4 and 5, or 2 and 3, I think it is up here. Is it 2 and 3? Yeah, 2 and 3. Put a short on here, so it shorts the input of the regulator. So to me, because I couldn't get to these tracks here easily, it looked to me like there was a short on the output. It's only when I disconnected this cable after lots of messing around, realised that there was no problem at all, any shorts on the input here. I reconnected it up, cleared the short. I thought, okay, I spotted the short on the connector, what I'd done wrong there. Cleared the short, powered it up, still no output, nothing on these regulators. So I'm thinking, well, maybe I've blown the resistor. Check the resistor. These resistors okay. The collectors had their voltage on, nothing on the emitters. Right, okay, so the transistors aren't turned on. So we follow these, track these through, and we track these through to this CN18 here. And this CN18 also was one of the ribbons I disconnected, and they were the same problem. One of the pins wasn't even connected. So, I mean, it's not easy to spot. You have to get it at just the right angle and peer in, because there's not a lot of room. Reconnected that up, transistors turned on, amplifier worked, phono stage worked correctly. So yeah, as I say, it's quite a bit of a sort of like a long-winded state for these phono amplifiers. We've got these two transistors here that put a shunt across the output and act as a muting circuit for the phono stage. That's quite a good idea, but it also unpowers the power supply for the phono amplifier when it's not actually being used, which I suppose is a pretty good idea, really. Why do you want the phono amplifier running in the background when you're not using it? So I know I had a bit of a moan about it and saying it was unnecessarily complex, unnecessarily complex, but to be honest with you, I suppose it's a good idea. I mean, it's not going to save an awful lot of power. The quiescent current thing of this is about 60 watts, I think, in idle. 60 watts in the mains. So you're only going to save a quarter of a watt, half a watt, probably, with that phono amplifier being turned off. So it's all back together anyway. I don't know what to make of it, really. It sounds alright. I mean, this isn't a great test plate. This workshop isn't a great test area to test amplifiers, but it doesn't excel in its sound quality, I don't think. It's certainly obviously a very powerful amplifier, and I've been looking at reviews of people who've owned these and to see what they think of them, and most people there's no one that says they're really great, they're fantastic, apart from the people who say, oh yeah, they're really, really powerful. Yeah, they are really, really powerful, but it's a high fidelity amplifier. I'm more interested in what it sounds like more than the power it makes. It sounds alright, yeah, it sounds okay. I don't think it sounds any better than any of the other amplifiers I've been testing recently. I've also, my main amplifier I use at home at the moment is a Pioneer A400, and I think that was always regarded as a pretty good amplifier. I'm not sure it sounds as good as, this sounds as good as the Pioneer A400. Doesn't matter really. It's, it depends on your hearing, really. It depends what sort of sound you like. This sounds to me a little bit harsh and surprisingly a little bit sort of bass light as well. though the frequency response was okay. It was a bit, it wasn't smooth, it wasn't as, you know, a smooth flowing waveform. I think what I might do later on this evening, I might do a follow-on video and just run it through the power, the 8562A audio analyzer, just to see what sort of response we get on a plot, rather than just looking at the waveform. Or I could run Peak Millet software, I suppose, from the Hewlett-Packard and do a proper plot on that. But that'll be for another video, I think. I've got it going. I'm quite happy with the result. Might try it at home if I can find a cabinet that will take the weight. And yeah, that ends this video on the Pioneer A757. Thanks for watching.